Hello everybody and welcome to lesson number 10 of our Scratch course. Let's jump right in. Okay, today, well last time if you remember we dealt with data types that Scratch offers. There were three types of data types. The Boolean, yes, no, true, false. The how to create and use your variables. Remember how to create the variable for this sprite only and the variable for all sprites, and the difference, the only real difference between the two was, if you recall, for the variable for all sprites could both read the value and update it or change it, whereas for this sprite only, although all sprites can access the variable to see its value, only the sprite that owns it can actually change its value. And let's remember that for variables allocated as this sprite only, you could repeat or reuse the name of the variable in each of the different sprites. So you could have a speed variable for 3 different sprites without a problem, but if you had a variable called speed for all sprites, then you could only use that name once, and you couldn't use that name again for a local variable either. We also looked at how users can use variables to store information and that type of thing. And then there was less problems number 1 and 4. I hope you guys managed to look at that, and please remember to look at lesson number 9 for a recap of last time's lesson. Today's goal, we're going to look at variable monitors, getting input from users, and then we're going to get a bit different. We're going to try something different today. Unfortunately, for those of you that couldn't make it, you won't be able to participate, but it's very much an interactive day today. So I'll show you what we did, so you just get an idea of roughly what actually happened. And then we're going to look at developing your code from specifications that we will give. Okay, so we're going to look at using variable monitors in programs. I'll show you what that means just a bit now. We're going to look at an example of user interaction using those variable monitors, and then we're going to have, as I mentioned, the quickfire development session, and then developing an application just based on what the user requirements are. So what if you're writing a program for somebody else and they give you what they need or want, how do you go about doing it? Or we're going to test to see how well you can do it. Okay, variable monitors, it's basically being able to see the value of a variable on your stage. So when you go and define your variable, you'll see this little checkbox next to it, a little tick box, and if you tick it, on the screen a little variable monitor will appear with the name of the variable and its value next to it. As you can see there, the score object, so our variable score and the value it's currently holding. However, the one thing that's different is that if you create a variable for all users, all sprites, you'll see that the variable name will be speed and its value. However, if you are using a sprite which you've defined for, a variable that you have defined for the sprite only, what it does is the monitor will prefix the sprite name, colon, and then the name of the variable. So if you do have 2 or 3 speed variables for different sprites, each one will have the name of the sprite in front of it. So it'll be cat, dog, donkey, whatever you're using, and you can see the individual speeds, so it's easier to keep track of and monitor what's happening there. So it's basically variable monitors. Once you've got your variable monitor up, you do have the option of allowing the user to change that value through the use of a slider. So as you can see here, we have a little sliding ball there. So if you right click on your variable, this little menu pops up, and when that pops up, you can then choose to make it a slider. And if you have chosen to use the slider mode, you can then go and say set the min and max values. So let's say you want the user to only enter a value between 1 and 10, you can then set the minimum value to 1, the maximum value to 10, and they can only therefore enter those values. And your scroll, this little ball here, when you're to the extreme left side, will be 1, and as you move it along to the other end, it'll climb up to 10 slowly. If you don't do that, it might climb to very high values, which might not be what you're looking for. So looking at an example down below, you can use it to do things like changing the color of your stage. So as you can see here, you've got your variable, stage color, inside a color effect. And then if you write this bit of code, and as you slide this variable and this number changes, so the color of your stage will change. And that's basically using how you would set up your variable and how you can use it by the slider. I'm going to jump to a quick example here. I don't expect you to know what Ohm's law is, but this is just a demo to show you how you can go about putting together a bit of a presentation and then allowing the users to adjust the values to see the result of what they are looking at. So Ohm's law very basically is the law of voltage and current in relation to resistance. So here's the basic equation. So you can say voltage is equal to I for current times the resistance of the circuit. So if your resistance, let's just give it a value of 10, is a constant value, then as voltage increases, so let's say voltage goes from 10 to 20, and that's a constant value of 10, obviously I will grow from a value of 1 to 2. So 1 times 10 is 10, 2 times 10 is 10, and so forth. But let me just show you how you can then live demo this. So here's the actual application running. So for those people who are interested in Ohm's law and would want to know how it worked, you could probably put something to you like this. And then as you can see, as I, let me just make sure it's running, as I increase the voltage, you can see how both the V and the I are growing together, how the current, that's the I, that value belongs to I, R is 1, so V equals I times R is 1, so 5 equals 5, very simple. So as I increase the voltage, so the current increases, and so the light bulb gets brighter. Now we go back down again, it gets dim again, right again. Now if I had to increase the resistance, so how much the light bulb resists current flow, so you can imagine like a tap. So I'm now closing the tap a bit, making it more difficult for the current to flow through the light bulb, so making R very big. This will force the current I to remain low as I increase voltage, and so the light won't get as bright. Okay, but you don't have to truly understand what's happening here, but this is just an example of how you can put together a presentation to show a scientific rule or experiment, and how people can, by playing with values, can make things happen. Okay, that's just a quick example of how you can get users to give you a bit of input and how it can react to that input. Okay, now unfortunately you couldn't do this. What we did, we jumped onto the wheel of coding. So very basically what we did, what this is a quick fire question answer session. So I'll show you what we did. So here we have it. We're going to click on me and let's see what pops up. Motion. How would you add another sound to the list? And everybody would raise their hands and try and answer this question. And the answer to this question very quickly would be, you would go to your sounds tab under your sprite, click on the little icon, the first or second or third icon depending on what you want to bring your sound in. You would then bring in a sound, and once you've done that, it would then appear in this list. Let's try one more time. For a while. When space key pressed, which keys are needed to move your sprite in 4 different directions? Okay, interesting enough, this one took a while for everybody to come up with the actual answer, but it's a bit of a tricky question. That's a trick question, in that any key can move your sprite in the 4 directions. So you choose which keys move your sprite. Just remember, the key itself doesn't move it. You would just monitor the event for a key pressed, and then you would go and say move or change X by 10 or move 10 or whatever. So this is a bit of a trick question, so just remember that things that you might think are obvious aren't always obvious. Okay, and then so forth, then we carried on with that. Okay, and that was Wheel of Coding. Then we jumped into Mission Impossible. Pick your mission. This was where we gave all you young soon-to-be developers the opportunity to see if you could develop something based purely on specifications or requirements. There were 3 options. There was the Breakout game, which is as follows. So here's the Breakout game. The basic requirements were, I have a paddle, a ball, let's see now if I start it. I have 160 little tiles, and basically I wanted to break out of here and try and clear it, and that was it. Mode 0 and mode 1, the difference was on mode 1 I would like, if you'd like to try this, to be able to control the ball. So you'll see as if I can bounce the ball to the middle of the paddle, yeah, not very good, it goes almost straight up, and then closer to the edge, oops, closer to the edge, the sharper the angle. So basically I can use the paddle to control how I want the ball to bounce. So I get it in the middle, and I can get it to go almost straight up like that. Oh. In mode 0, the ball bounces randomly off the paddle. Regardless of where I hit it, it can bounce at any angle it likes. So even on the edge, I have no idea where it's going to go, and in the middle, so forth. As you can see, it's bouncing around. So that is basically Breakout. What we gave the class was a sprite, the no-code version, which included a sprite for the paddle, a sprite for the ball, and a sprite for the tiles, and we asked them to go and using whatever method they thought best to make the tiles and so forth. This was the first project they could try and tackle if they wanted to. The second project was Up Tera, which seemed simple, and I'll demonstrate to you now, but quite a few people battled, and I think only one really succeeded. Let's show you what Up Tera was. Basically, Up Tera was, if I click on Tera, if I click on any item of clothing, that item of clothing would go to Tera. The catch was, if I moved Tera, the clothes had to follow, and if I started again, regardless of where I put Tera, the clothes had to find her. That was the requirement for that one. As you can see, not too difficult, but people battled, and that is a requirement for that one. And finally, we had the Polygoner. This one we gave no code or any sprites or anything, because it was purely a pen function. So here is Polygoner, and basically the requirements were, I want an application where I can choose how many sides my polygon base item must have, and how many times I must repeat it in a circle. So the most basic was I want a 3-sided polygon, a triangle, and I want it to repeat 3 times. So there's my triangle repeated 3 times, and within the polygon I wanted to have 10 smaller versions, or 10 versions growing bigger. So I changed it to 4. There's my square with 10 squares inside it, rotated. I change this to 4 squares, 4, and so forth. So you can go really wild and get some really freaky patterns. Okay, this was Polygoner, and if we go to the extreme, we get some really cool patterns. That was what we asked the class to do. Pick one and go ahead and do it. And they were given an hour to see how far they could get. Let's just say that that hour was well spent, and many realized that although they've got the knowledge of what each thing does, how you break a problem down and solve it is not that easy. And so we'll be looking probably in the next few weeks, for those who continue with us, how we went about developing each one and how you break it down to try and solve the problem. So homework, problems 5 and 9 out of sessions 9 and 10. Check out lesson 9 from last week. This one should be available if you're watching it as of Monday. Next lesson we're going to look at decision making and logical operators. So basically, how do you get your program to make a decision based on some form of condition or event or Boolean activity. Thanks very much, and we hope you decide to join us for the second half of the Scratch course, lessons 11 through 20, where we'll be tackling things slightly differently.